Welcome to this tutorial on data clustering using the k-means algorithm in Java. In this video, we'll explore the fundamentals of k-means, implement it from scratch, and explain how to tune its parameters effectively. To begin our journey, let's first understand what data clustering is. In essence, clustering is the task of grouping a set of objects in such a way that objects in the same group, or cluster, are more similar to each other than to those in other groups. K-means is one of the simplest and most popular clustering algorithms. The K in k-means stands for the number of clusters we want to identify. The algorithm assigns each data point to the nearest cluster center and then recalculates the cluster centers based on the assigned points. Now, let's outline the steps for the k-means algorithm. 1. Choose the number of clusters, k. 2. Initialize k centroids randomly. 3. Assign each data point to the nearest centroid. 4. Recalculate centroids based on the assigned points. 5. Repeat steps 3 and 4 until the centroids no longer change. First, we need a dataset to work on. For simplicity, we will generate some synthetic data. Let's create a Java class to create random points. This data generator class has a method called generateData that will produce random points around random centers for a specified number of clusters. Let's now use this in our main function to create some data. Now that we have our synthetic dataset, it's time to implement the k-means algorithm itself. Let's create a class named k-means. In the k-means class, we have defined the basic structure including the constructor and methods for initializing centroids and the framework for assigning and updating clusters. Next, let's implement the assignClusters method. Inside the assignClusters method, we will iterate over each data point and determine which centroid it is closest to. We will create an array to store the cluster assignments and compare it with the previous assignments to check for changes. Next, let's implement the updateCentroids method. This method will calculate the new positions of the centroids based on the current assignments of data points. We've now built our k-means algorithm. Let's put everything together and see it in action. We will modify our main method to include the fitting of the k-means model. Now that we have executed the k-means clustering, let's add a method to visualize our clusters. Visualization can greatly help us understand the clustering results. The visualization class uses Java's Swing components to draw our data points colored according to their cluster assignments. Now, let's see how to integrate our visualization with the main program. Now we can run our program, and it should display a window with colored points that represent different clusters. What you see is a direct result of how well k-means has grouped the data based on their proximity to the centroids. Next, let's discuss some important points regarding the k-means algorithm. One significant aspect is how to determine the optimal value of k. One common approach is the elbow method, where you compute the sum of squared errors for different values of k and plot the results to find the elbow point. Another important aspect to consider is that k-means may converge to different solutions based on the initial placement of centroids. To mitigate this, it's recommended to run the algorithm multiple times with different random initial placements. Let's add functionality to perform multiple iterations and select the best result based on SSE. This modified fit method allows us to run the k-means algorithm multiple times to find the most favorable clustering results based on the lowest SSE. Implementing this can significantly enhance the performance of the k-means algorithm on various datasets. Finally, let's summarize what we've learned in this tutorial. We delved into k-means clustering, explored how the algorithm works, and implemented it step-by-step in Java. We also dealt with challenges such as selecting the right number of clusters and handling centroids initialization effectively. Thank you for joining me in this deep dive into k-means with Java. Make sure to check out the repository linked in the description for the full code. Don't forget to like, subscribe, and hit that bell icon to get notified about future tutorials on data science and machine learning.